welcome to today's class. My name is Shegun Oke. So we continue from the last class where we stopped. So in the last class, we were able to discuss the gradients. The gradient is divided. It said let phi of s, y, z be defined in this way. So are differentiable at each point of x, y, z. So we proceed from there. Then we have the del that distributes the file around them. But now, that's not the issue for today. Today now we'll be looking at another aspect of it, the components of file. We note that the file is a vector field, like we defined yesterday. So for today, let's look at this, the divergence. But before the divergence, we said the components, continue from where we stop, of phi, of del phi in the direction are we there?
Yes, sir.
Of a unit vector, unit vector A is given by phi dot A and is called the directional derivative of phi, directional derivative of phi in the direction vector A. Physically, this is the rate of change of all of phi at s, y, z in the direction vector A. Now, let's look at this. Today we'll be looking at the divergence. I told you we have three things. We have core, we have gradients, we have divergence. So these are the things we'll be discussing. And if you check the past questions, you will see the question on those areas. So here we have divergence. Let's look at the definition. Let V of s, y, z equals to V1 I plus V2 J plus V3 K be defined and differentiable. At each point, x, y, z, in a certain region, of space, that is, our V defines yes. Dorcas, you raise up your hands. Dorcas, you raise up your hands. Please speak.
Sir, please, can you scroll up a little bit, sir? I missed the...
Don't worry, I will
Yes,
send the video to you. Anyone you miss, you continue from there. Don't worry.
I think Doka said she can't hear your voice. That's what she's typing. She just sent to me on WhatsApp now.
Well, if she can't hear my voice, that means she did not connect to the audio. She can log out and log in again. Or check your network. That is, V defines a differentiable vector field. Then how do we write it mathematically then?
Hello, sir.
Yes.
Yeah, good evening, sir.
Good evening.
Yeah, the board is not centrally positioned.
It's because of your network.
No, I mean the board, not network issue. It's not centrally positioned, sir.
Others, can we see the board clearly?
Clearly, sir. Yes, sir. Yes, sir.
No, I'm seeing it clearly, but some part is cut off.
No, probably maybe when I move it up. Can you see it now?
I can still see it, sir. It's just that some part, the right-hand side is not complete.
And that is what I'm saying. Probably because I move it. So it's because you did not join us from the beginning. Don't worry, you have the video, you will see everything. Is that okay?
All right, sir.
No problem. Just continue with
okay, sir.
The divergence of V written, this is what we call del multiplied by V, or def V. So when you have the del dot V, what does it mean? It simply means d dxi plus d dy j plus d dz k dot v1i plus v2j plus v3k. Remember, when we have a dot b, it's the same thing as a1 b1 plus a2 b2 plus a3 b3. That is component by component. So we're going to do the same thing to this one. So it's going to be, implies that the v1, the x, plus the v2, the y, plus the v3, the z. Note that the v dot v is not equals to v dot v. V dot depth. Please take note of that. Let's note this. So now let's look at the third definition, the core, before we now do the example. The core. If V, S, Y, Z is a differentiable, is a differentiable vector, it's a differentiable vector field, then the core or rotation of V, comma, written there cross V is called core V, or Roth V, is defined by del cross V is equals to d dx plus d dy j plus d dz k cross by v1I plus v2j plus v3k. Remember, anytime you are doing the V, you are doing the cross, we always approach it with determinants theorem. D dx v1 j is d dy v2 k v3, which implies we can now solve it using determinants theorem by saying d. Remember, when you pick I, remember plus, minus, plus. When you pick I component, all these rows will be parallelized. Then you pick this one. The row the I belongs to will also parallelize. You are left with d dy v2 d dz v3 minus, because of negative here, you release this one, this column will also be parallelized. It remains 1 d dx v1 d dz v3 plus, release this one, you pick this. What do we have? D dx v1 d dy v2. Don't forget the component I, the component j, and the component k. So from here, we can now proceed by putting everything together. So this multiplied by this, and this multiplied by this. So we have, in bracket, V3 dv3 dy minus dv2 dz. Everything I minus dv3 dx minus dv1 dz. This is j plus dv2 dx minus dv1 dy. Okay. So that's just the how to write this particular one. And we have a lot of definitions. Because of our time, I will ask you to go and read them, but let me give you a few of them. I'll just give you formulas so that by the time you are given the question, it will not strain to you. Number one formula says, when you have V del into dots, del multiplied by phi plus psi. It's the same thing as del phi plus del psi. Number two, we have del dots A plus B. Z dot A plus del dots B. Number three, we have the gradient, which is grad of phi plus this plus psi. The same thing as grand phi plus grand psi. Number four, we have A cross this is the same thing as A cross del cross A plus del cross B, or cos of A plus B is the same thing as cos A plus cos B. So if you actually check your book, we have a lot of definitions out there. How many of us have access to the book? But five. Okay. Dot phi A equals to phi dot A plus phi grand dot A. Let me just stop there, because anytime when we are solving the problem, I think I'll be giving us as many as possible. But before then, I think this is paramount that I need to share with you guys. Del dot del phi, same thing as del squared phi, which is equivalent to the square phi, the s squared, plus the square phi, the y squared plus the square phi the z squared, where del squared is called, or is equivalent to the square the x squared plus the square the y squared plus the square the z squared, is called Laplacian operator. Laplacian operator. Seven is del cross del phi equals to 0. Please take note of that. Anytime you have call of the gradient of the file is 0. Then 8, when you have del dots del cross A is also 0. Anytime you have a divergence of the core of A is 0. So let's look at the example. Let me stop there. Let's look at the example of gradients first. Example. The gradient. So number one example, if phi of x comma y comma z equals to 3x squared y minus y cubed z squared. Question is find the of this, or grad of this, or call it grad of phi at the point 1 comma negative 2 comma negative 1. So how do we solve this problem? It's very simple. All you need to do is define yourself. This is phi, which is, we know, you first of all define this one for us. So multiply by 3x squared y minus y cubed z squared. You have to be careful in this case. Remember, it's not dots and it's not cross. It's just multiplication. So what we need to do now is, this is our phi. You'll be taking it into consideration. I dot d dx of the entire equation plus j will be d dy of the entire equation plus this is k, d dz of the entire equation So how do we solve this one? We can easily solve this by differentiating. The first one is we differentiate with respect to x. That is the first thing, because they said d dx. So the d dx, this one, you have 6y or 6x. Let's start with x. 6xy I. Don't forget this I. Don't forget these components. they are key to the direction. Then plus, we need to differentiate y. So if it is y, we have 3x squared minus 3y squared z squared. That is y. To component j. Then for the z plus, how do we differentiate this one? So what do you have? You have minus 2y cubed z, or with k. And don't forget, we have given a point at x equals to 1, y equals to minus 2, z equals to z equals to what? Anybody? Yes, are we together?
Minus 1.
Minus 1, thank you. So
Yes.
we can substitute it now. We have 6 in brackets, 1 in brackets, minus 2, I, plus 3 in brackets, 1 squared, minus 3 in brackets, minus 2 squared, and z raised to power 2 j. So minus, because of the minus we have there, 2 in brackets, minus 2 cubed, and minus 1, and minus 1. So you can see it's very simple. All you need to do is just multiply this one. You have minus what? Minus 12i. This is 3. This is 4. 4 multiplied by 3 is 12. Plus 1 square is still 1. So you have it to be 3 minus minus 12 j minus, this is minus 8 minus times minus 1 positive, you have 16k. So at the end of the day, you have negative 12i minus 9 j minus 16k. So that is what they ask us to use anytime you are given the grant to solve. Any question? No question. Silence means no question. We can proceed. But let's look at number 2. It said find the direction. Find the directional, is directional, directional derivative of your phi equals to x squared z plus 4xz squared at 1, negative 2, negative 1. In the direction 2I minus j minus 2k. So to solve this problem, in case you're given the one with direction, how do I handle it? This is what we have to do. Phi of this is equals to this del of the entire equation, which is x squared yz plus 4xz squared. So how do I do it? Remember the definition, the way we solved the graph the other time. You have I dx of the entire equation plus j d dy of s squared y z plus 4x z squared plus d dz so d dz of the entire. Don't forget your component. I can quickly differentiate this one, then move on. So for us to differentiate this, you have 2xyz plus 4 squared I plus, we need to differentiate y, you have x squared z j plus s squared y plus 8xz. Okay. Any question? Silence means you got what I'm doing. So let's look at our point. Remember, the question is giving us this. We're given some points. The point x is equals to 1, y equals to minus 2, z equals minus 1. So we can proceed by substituting this value there. So you have 2 into 1 y is minus 2 and z is minus 1 plus 4 into minus 1z. Everything here is still I plus, open the one of k, j. 1 squared and minus 1 and minus 1. Everything is j. For k plus k, we have 1 squared y 1 squared negative 2 plus 8 into 1 negative 2 j k rather. So if you solve it very well, what do you have, please? This is negative, this is 8, 4. Anybody? So here is -1. Don't forget, -1 squared. So you have so the next thing is let's use our I. If you do it
Sorry,
very
sir.
well, you have 8I minus j minus 10k.
Excuse me, sir.
Yes.
So the last part, the 8 brackets 1 minus 2 is supposed to be -1 because z is
-1. Thank
minus
you.
1. Yes.
Thank you. Are we all together now? So at 1, -2, -1, that's why we have this. Now, we need to calculate the unit vector in the direction. Remember, we are given a direction of 2I minus j minus 2. A equals to 2I minus j minus 2k divided by the same absolute value, square root now, which is 2. So at the end of the day, remember we are still working on the direction. So we have it to be let's solve the one in the square root. Denominator. The denominator will be 4 plus 1 plus 4, which is square root of 9, which is equals to 3. So it simply means 3 will divide each of them. So we're going to have A to be equals to 2I over 3 minus 1 all over 3j minus 2 all over 3k. Any question? Any question? So,
Excuse me, sir.
yes, ma'am. Aderonke,
Sir, I don't understand the last part you did. When you're talking about the direction of the 2I minus j.
Now,
I don't know
let's
how
go
you
back
get
to
the
the question.
2.
Let's go to the question first. Let's read the question. The question says, find the direction derivative of phi equals to x squared plus x squared y z, right? Plus 4.
Yes, sir.
So, and we are plus 4x z squared at this point. So after that, the answer in the direction of 2I minus j minus 2k. Now, after you finish this, the first part finish at this point. We finish the first part at here. Let me use this pen. We finish the first part here.
Yes.
So for us to not get to the direction we are looking for, you need to first of all calculate a unit vector. Are you following it? So
Yes,
that
sir.
unit vector will now be the one you will use to multiply the depth of I've already gave us the definition for those of us that came earlier. I gave us the definition of direction. Let me just scroll up a bit. Don't worry. You will see the video later, but let me just quickly say this so that you will understand what we are doing. Now, from here now, look at it. It said, look at it, it said, the component of del phi in direction of a unit vector A is given by del phi dot A and is called the directional derivative of phi in the direction A. So that is what we are doing now. So at that point, physically, this is the rate of change. This is the rate of change of phi at x at the point of this one, at this point that we are talking at the point of x, y, z in the direction A. So what we are doing is still the same thing of that definition that I gave earlier before some of us joined the class. So we are still on course. So it simply means we first of all get our A. The definition he gave us, he said get your A. Now, after you now gotten your A, for us to now solve the problem, we now said then, let's continue here. I hope the lady that just asked a question now, Aderonke, I hope I've answered
Yes,
you.
sir. Yes, sir. Yes, sir.
Okay, let's continue. Then the require directional derivative is, look at this is the definition, multiplied by phi dot A. Let me write it again. Dot A is the same thing as, don't forget, we've calculated this one, which is the one that I started here. This is it. This is the point we are talking about, this particular point. So multiply by our A, which is this A. So it's going to be dot A. Now let's look at it. It's going to be 8I minus J minus 10K dot 2 over 3I minus 1 over 3J minus 2 over 3K. So now, if I take the dot of dots, remember dot I is equals to 1. You remember. So it's going to give you this. So we now multiply this. This will multiply, let me use this pen. This will multiply component by component. So it make it simple. So we have, the first one will be 2 times 8, or 8 times 2 will be 16 over 3 plus negative times negative positive will be
Good.
plus 1 all over 3. Then negative times negative positive will be 20 over 3. And you add everything to that, you have 37 over 3. So that is what they ask you to solve. Any question? Okay. Silence means
Well
no
understood.
question. Yes?
I said well understood, sir.
Okay, you're welcome. So let's look at another example on divergence now. So, and that's the two questions likely they ask you in that aspect, and you need to learn how to solve those stuff. So let's look at this divergence. So number one example is if A is equals to x squared zi minus minus 2y cubed z3 z2 rather j plus xy squared zk. Then I said find def a dot a.
Please, sir. This screen is not clear, sir.
No, it's because of your network.
Sorry. Okay.
There's no network, sir. My own is still showing the same.
Your own is what?
Mine
It's
is also
showing
saying
like a block.
the thing
It's
is
not clear.
blunt.
My own too, sir.
So can we
I
see
don't
it
think
now?
it is.
No, sir. Still blur.
How many of us is block?
All of us, sir.
All of us, sir.
It's blunt, yes, sir.
It is now clear about in small town.
Is it clear now?
It's okay now, sir.
It's
Yes,
okay,
sir.
sir. Yes, sir.
It's clear.
Okay. It's network. It might be from my side, it might be from your side. That's why I just can, so that probably it will correct itself. Okay, at the point 1 comma negative 1 comma 1. So the question says if A of this, find this. Now, this is dots, don't forget. It simply means anytime you see dots, it simply means you cannot get the component again. You will definitely get the normal answer, solution or figure rather. So it's going to be def dot A, which is same thing as d dx plus d dy j plus d dz k dot s squared z I minus 2 y cubed z squared j plus xy squared z k. It's still the same thing. I just want to rewrite it. Okay, so for us to solve this one, what we need to do now is it's all about components multiplied by components, not the entire, the way we did the other time. So what you need to do now is to pick d dx into, that is I dot I, y dot y, k dot k, j dot j. So because Others, when you are picking the other component, the other one will turn to 0. That's the meaning. So you just pick the one you need for each of the components. You don't need to put I again because I dot I will turn to 1. So plus so we have 2 negative 2 y cubed z squared plus x y to z. So now let's differentiate this one. You have 2xz minus, because of this negative, we have to differentiate y here. You have 6y squared z squared. Then plus xy squared, because you differentiate this one. Remember, you were given at 1, negative 1, 1, meaning x, y, z. So I will have 2 into 1, 1, minus 6 into minus 1 squared, 1, plus 1, minus 1 squared. So the final answer in this case will be what? You have 2 minus 6 plus 1. You have what? Minus 3. So that's the answer for this case. Any question? Silence means no question. So we proceed. So in a situation whereby you are given another equation, number 2 of the divergence, so you have phi given, let me write it correctly, given phi equals to 2x raised to the power 3, y squared z raised to the power 4. They said find a dev dot dev phi, which is simply means, or dev grant then B, show that dot is equals to, we are asked to show this, where Laplacian operator is equivalent to the square the x squared plus the square the y squared plus the square the z squared. Denotes the Laplacian operator. So how do we solve this problem? I know when you see the equation, you'll be like, oh, which question is this man is giving us? Oh. So it's very simple. All you need to do is just to follow the rule. Are we together? Can you hear me?
Yes, sir.
So for us to follow the rule in this case, we first of all calculate the grant. The first question says, yes, Ronke?
There is a mistake, sir. Can continue.
Okay. So the first thing we need to do is I d the x, we find the grand of the file. The file is 2x cubed y squared z4. Remember, you can't separate this one. It's all just only one. Plus j d dy into 2x cubed y squared z4 plus k d dz of 2x cubed y squared z4. So everybody differentiate this. Let's see. Yes, you have 1 minute to do that.
So I can't hear anything now. I don't know if it's network.
He asks us to differentiate it. Do
Yeah,
the differentiation.
I'm done with the differentiation. It's like it's offline.
Please, can anybody hear me or is my network?
Yeah, it's just that we cannot hear our facilitator. I
Okay.
don't know.
He said he gave us 1 minute to do the differentiation.
It's
Maybe
more than 1 minute now.
he might go and
Yes,
eat it
and
up now.
so have you finished your
Oh,
own?
oh, sorry, sir. I thought you were not there, sir. Sorry. Yes, sir.
I'm there. I hear everything.
Sorry, sir.
If you've solved your own finish, raise up your hand. Tell us the answer. You see? Nobody raise up the hand now. Only 1, 2. So Samuel, tell us first thing.
Okay, so I have 6x squared, y squared, z raised to the power of 4, I.
Let me write it along with you. 6x squared, y squared, z
Y
raised to the power
squared,
4.
yeah, I. Then plus 4s cubed,
Plus 4s cubed,
y, z raised to the power of 4, j. Plus 8s cubed, y squared, z raised to the power of 3, k.
How many of us got this? If you have the same answer, just raise up your hand. Okay, others, what happened? Have you seen where you missed it? Correct. Let's continue. So that is first part. The second part now says we should find phi dots. So we have this one. We need dots ground. So it simply means we need d dxi plus d dy j plus d dz k. Dots, open the bracket, everything you have up there, the one you just calculated now. So at the end of the day, in this case now, component by component, don't forget, d dx of 6x squared, y squared, z4. There will not be any component again, plus d dy j 4s cubed yz raised to the power 4 plus d dz 8x3 y squared z raised to the power 3. So we can go ahead and differentiate this one. If you differentiate this one, what do you have? The first thing we have is what? With respect to x, 12x y squared z4 plus 4x cubed z4 plus 3 times 8, please.
24.
So that is what we have. So the next thing says, show that the next thing says, show that, which is B. Depth of this is equals to the square of it. So, which implies it's the same thing as d dx I plus d dj yj plus d dz k dot the phi dz the xi plus the phi, the yj, plus the phi, the zk. So don't forget, we'll now be taking it one after the other, the proving. You know, the component by component, meaning the square I, the square phi, the x. Okay, maybe I should write it one after the other so that you understand what I'm saying. D dx is brackets. You agree with me? Hello?
Yes, sir.
So which is the same thing as the square phi, the x squared, plus the square phi, the y squared, plus the square phi, the z squared. Now, how do we now say this is equivalent to what we have all? All we need to do is just implies that this squared, the x squared, plus this squared, the y squared, plus this squared, the z squared, multiplied by 5, which is equals to the square 5. So that's what they asked us to do. Any question? Hello? Is it like magic?
Hi, sir.
I don't think so. Some of you,
Sir.
you know what? I always laugh when some of you, they are doing the degree like this. You believe that probably they will lower the, you are doing part-time or you are doing online program does not mean we will not teach you what is necessary for this degree. Am I speaking your mind? Because some of you believe, oh, it's not supposed to be hard. It's not hard. It's just a normal procedure. If you want to tell me tomorrow that you graduate, you feel you are a graduate of mathematics, I should be able to ask a question in this area. I should be able to answer me. You should be able to be in my position tomorrow to teach others the same thing I'm teaching you. Is that okay? So
Yes,
see it as an opportunity to learn and make sure you learn more. Yes, any other question? Are we tired? Are we tired? Okay. Silence means we are not tired. Okay, let's continue. Let's do the other aspects, which is the core. Example for the core. I'll just solve one or two examples then we'll finish it all. Now, if A is equals to xz 3I minus 2x squared yzj plus 2y z raised to power 4k. Now say find del A cross del, let's say call cross A. Let me put it that way. Or call A. at the points 1, minus 1, 1. So what does it mean? The solution is here. Let's look at the solution. The solution says call A is the same thing as d dx I plus d dy j plus d dz k. Cross your A, x z3 I minus 2x squared yzk plus 2yz raised to power 4k. So how do we solve this? Remember, anytime you have a cross, you use determinants theorem to solve it. So you have I, which is d dx, j, d dy, k, d dz. Yes.
Please, sir, can you please help me to scroll down your screen so that I can write the coil?
Which of
I was
them?
disconnected before. Why?
Are you there?
Yes, okay. All right, sir.
Okay. Can I proceed now?
Yes, sir. Yes,
So
sir.
we have our I, J. This is J. And this is K. You have it xz3 minus can you see the screen? Can we see the screen, please?
It's not clear, sir.
It must be the network. Is it clear now?
It is, sir.
Yeah? Is it clear now?
Partially, sir.
Okay. So now that we have this, all you need to do is just to solve it determinantly. Let's pick I. Remember, when you are picking I, this is row we parallelize. The first column will also parallelize. That means we have I into how many remaining? You have the dy minus 2x squared yz d dz 2yz raised to power 4, then minus j, which is you release this one, you parallelize the j column, which is d ds xz3 you release this one, then you parallelize the last one, so which is plus k we have d dx xz cube d dy minus 2x squared yz. Now, we need to now harmonize them by saying our I is still here. We have d. Don't forget, we are picking them. This multiplied by this, multiplied by this multiplied by this. So what will happen is we have d ds multiplied by y there is a 2 here, multiplied by 2 y z4 minus dz multiplied by the other side, dz minus 2 x squared yz.
Excuse me, sir.
This is
How
our
much is
high.
d dy, not the. What is d dy? Not d ds. Not d.
It's supposed to be y.
Yes, sir.
Yes, thank you. Minus j. For your j, let's look at the j is x. J will be d dx of 2y z4 minus d dz xz3. So plus k, let's see whether it can maintain it, d dx of minus 2x squared yz minus d dy of x z3. Okay, so we can now solve them one by one. Let's solve the component I first. Differentiate the first one with respect to y. What do you have? You have 2z raised to the power 4. Am I right? Remember, this is minus. Minus times minus. Plus. You have 2x 2x squared y. Everything is I. Minus, let's look at the j. If you differentiate this one with respect to x, is 0. There's no x. Differentiate with respect to y, to z. You have minus 3xz squared j. Now, differentiating with respect to x plus k, we have minus 4 x, y, z. Differentiating with respect to y, minus 0. Any question? So let's see what we have at the end of the day. We have 2z raised to power 4 plus 2x squared y I minus times minus plus 3xz squared j minus times plus minus 4xyz k. So at x equals to 1, y equals to minus 1, z equals to 1. So substitute it here. What do you have? You have 2 you have 2 y raised to the power 4 plus 2 into 1 and negative 1. I, you have 3 into 1, z into 2, j, minus 4 into 1, minus 1, z1, k. So what do we have here? The first one is what? 0, I, plus 3, j, then plus 4k. So our final answer will be 0i plus 3j plus 4k. Any question? So can I stop sharing the screen, please? Can you hear me? Hello?
Hi, we can hear you, sir.
Okay. So I believe what we discussed today will help you in solving some of the problems.
Yes, sir.
Aha.